to another tutorial on data analysis fundamentals brought to you by X Creations. This is lesson number 5. In lesson 4, we saw what non-parametric tests are, and we looked at the Wilcoxon test. In this lesson, we will walk you through the Mann Whitney U test. Alright, the Mann Whitney U test is a non-parametric test used to compare differences between two independent groups when the dependent variable is either ordinal or continuous. If it is continuous, it should not be normally distributed. The Mann Whitney U test compares whether the distribution of the dependent variable is the same for two groups. It is the non-parametric alternative of the independent sample t-test. When to use the Mann Whitney U test? 1. We use the Mann Whitney U test when the dependent variable is ordinal or continuous but not normally distributed. 2. When the independent variable consists of two categorical independent groups. And of course, the sampling was random from the population. And when we talk of the independent variable having independence of occurrence, it means that an observation is in one group and not in both groups. For example, if the group we want to compare is gender, and the observations we have male and female, a male should not be present in the female observations. Or let us say, in another example, the observations are people of different age groups. And so, a participant should be present only in one age group. You should not have a scenario where a participant is present in both age groups. Of course, this is more of a model rather than in statistical stuff. It's more of what you do when you go out to gather data. You ensure that the observations are independent. So, to use the Mann Whitney U test, your distributions of the independent variable can either have the same shape or they have different shapes. If they have the same shape, there will be a particular pattern to analyze to run the Mann Whitney U test. And if they have different shapes, there will also be a different way to run the Mann Whitney U test. Alright, the Mann Whitney U test is very useful. For example, in healthcare, it is used to know the effects of two medicines on a particular disease and whether they are equal or not. In business, it can be used to know the preferences of different people and whether their preferences change depending on some factors, say their location. In education, it can be used to know whether or not a particular group, say male or female, scores better in an exam than the other group. So let us demonstrate in SPSS using a fictitious data. And what we will be testing, we'll be answering the following question. Between induced therapy and normal medical care, when we talk of normal medical care here, we're talking of the usual way in which patients are cared for. Between induced therapy, maybe some sort of an additional thing has been brought in, maybe the use of supplements or some other stuff. Between these two therapies, which one is more effective in the management of wounds in the hospital setting? We want to know. The best test to use here is the Mann Whitney U test. If your variables meet all the factors that we have specified here in this slide. Okay, let us dive into SPSS. Okay, here is our data. In the therapy group, we have the very first group, which is the patients in which the induced therapy or in whom the induced therapy was used. There are 13 patients who received the induced therapy. This is our first group, and then this is the outcome of the wound, which is scored from 0 to 3. And then this is the second group, patients, the group that received normal medical care, group 2. And then this is the outcome. So if you look at the variable view, you will see that for therapy, we are coded as 1 and 2. So group 1 are the patients who received the induced therapy, and the group 2 are the patients who received normal medical care. And then when we look at the outcome of the wounds, we see that 0 are for the patients whose outcome was worse, 1 stands for good, and 2 stands for very good. And then of course we will see that the measure here is ordinal because it is ranked. And so, like explained before, for the Mann Whitney U test, the procedure that we will use in SPSS will depend on whether our two distributions, that the two groups, group 1 and 2, have the same shape or not. So how do we test for that? Okay, it comes to analyze, move down to descriptive statistics, come right to explore, click on explore, and our dependent variable is the outcome, the wound, the outcome of the wound. Transfer it to the dependent list, and then we transfer the type of therapy, which contains our two groups, into the factor list. And then we come here and click on statistics, come over top right, click on statistics, and we uncheck descriptives. We don't really need descriptives here. We uncheck descriptives and can check outliers. Click on continue, come down here and click on plots, then come up to plots, click on plots. We uncheck the stem and leaf, and we check histogram. Then we click on continue, then we take OK. Then we will have the two. This is the histogram for the induced therapy. The one down is a histogram for the normal medical care. If we compare the two, we will see that the shapes are not similar. Yeah, look, this one, come down, it goes up, and then this other one just goes up. And to look at it better, we can check the box plot here, and we'll see that they have very different shapes. Very different shapes. The shapes are not similar at all. So we are going to be using a different approach to do the Mann Whitney test. If these shapes were similar, like you have this whisk, there's no whisk here. If they were similar, like you have a whisk here and this one not too large, I mean, if they were similar, there will also be a different approach. So we see that the shapes are not similar, and so this is how you do it. Analyze using go to analyze. You will come down to non-parametric tests, then come down to legacy dialogues, then move down to two independent samples. Remember, we are using this method because our distributions have different shapes. Yes. Click on two independent samples, then our test variable is the outcome of the wound, and the grouping variable is therapy. You can see here that the Mann Whitney U test is already checked, and then we have to define our groups. We said group 1. Okay, we actually gave group 1 and 2. So in some cases you can have 0 and 1, or 1 and 3, depending on the codes you gave to your groups. So group 1 took the code 1, then group 2 the code 2. Click on continue, and okay. So we have here our results, and you can see that the mean rank for induced therapy is lower, it's 14.7, and the mean rank for the normal medical care is 16. So it shows that the normal medical care here is ranking higher than the induced therapy. But is this statistically significant? That's the almighty question that we are going to answer from this other table down here. And when you look at the p-value, which is the exact significance 2 by 1/3, you realize that we have 0.7, which is far greater than 0.05. So even though normal medical care is ranking higher than induced therapy, the difference is not statistically significant. So we can conclude that induced therapy and medical care, they almost have the same outcome on our patients. There's no difference. None is better than the other. Yes. So what if your data for the independent variable had similar shapes? If you run the test from the Explore tab and you had similar shapes, then you will not use the same procedure to analyze. You will have to come to analyze. You come down to non-parametric test. Then you will not go down to legacy dialogues. You enter these independent samples, and for the objectives you should choose customize, and then for your fields, okay, your objective is customize analysis. Come to fields and you transfer all the fields to the test field. Okay, in the fields, you look at it, you'll see that you have test fields here. So we're transferring our outcome to the test field. The therapy, we transfer into the group down here, group. Then you go to settings and make sure that the Mann Whitney U is checked. Okay, and then click on run, and you have this. First, you say retain the null hypothesis, and the significance is 0.7, which is far greater than 0.05 alpha level. So this is if your independent sample distributions had similar or the same shapes. So it was just a way to show you how to go about it. And coming up here, if you look, you see that we took the exact significance here because we had a sample size of 30. If you had a greater sample size, say 40 and above, you will not even have this exact significance here. What you have will be the asymptotic significance, 2/3. That is what you will use when you have a large sample size. Okay, so remember to hit the like button and of course subscribe to our channel. And in lesson 6 we will dive into the almighty chi-square test. See you soon.